Welcome to the Deep Dive. We're the show that cuts through all that information noise to bring you the insights you really need, to be genuinely informed. Today, our mission is, it's to take a really close look at some quite technical source material. We're diving into the HPE7-A09 exam guide. Now, that's an industry certification from HPE Aruba. But hold on, we're not here to study for a test. Nope. We're actually pulling out the really interesting, universally relevant bits of knowledge about how modern networks actually work. Think of it like a shortcut, maybe, to understanding these complex, invisible systems that, they power pretty much everything we do online.
That's a great way to put it. What's interesting about this material, even though it's for an exam, is that it gives a surprisingly practical view. How these complex networks are really designed, how they're secured, how they're kept running day to day. It sheds light on the basics that most of us use constantly without a second thought.
Absolutely. And just for context, the source mentions this exam is, proctored, 2 hours, 70 questions, needs a 68% to pass, delivered in English. But like we said, the real gold for you, the listener, is in understanding the actual networking ideas. So let's unpack this. Okay, so first things first. Everything digital needs to stay upright. Constant uptime. So a really critical piece is how networks handle failures, especially, right at the core. If you've got two main core switches, how do you make sure layer 3, the gateway part, keeps running smoothly if one fails, preferably without some super complicated protocol coordinating everything?
Yeah, that's fundamental. And a key feature the source highlights is something called active gateway in AOSCX. What's really neat about this is it allows both core switches, assuming they're set up in what's called a VSX pair, to simultaneously answer ARP requests. ARP, that's how devices find the MSC address for an IP. And they both use the exact same virtual IP and virtual NAS address. So it's not just failover, it's active-active. It provides gateway redundancy and load sharing. And importantly, it avoids the need for older protocols like VRRP.
Ah, okay. So it avoids VRRP. That sounds, pretty efficient.
It is. It simplifies things quite a bit for layer 3 redundancy in those VSX setups.
Are there any downsides or specific times you might still use something like VRRP instead?
Well, for most modern VSX deployments, active gateway is generally the way to go. It's simpler, it's active-active, so both switches are working. VRRP typically has one active, one standby, right? So one switch is just sitting there waiting. Active gateway uses resources better. The main thing is just understanding how it works specifically within AOSCX. But yeah, generally it's a big improvement for layer 3 redundancy.
Okay, so uptime is covered, but what about keeping different groups or maybe different customers separate on the same network? That's huge for security, right? Especially in big companies or, say, cloud environments with multiple tenants. How do you slice up that network logically? I hear the term VRF mentioned a lot.
Yeah, exactly. VRF, that stands for virtual routing and forwarding. That's the core concept here. Think of it like building internal walls inside a single switch. VRF lets you create multiple completely separate routing table instances on the same physical device.
Multiple routing tables. Okay.
Yeah, so each tenant or maybe each department in a company gets its own isolated routing world. The source points out its key benefit. It enables isolated routing tables per tenant or department. This is absolutely critical for logically separating traffic. Traffic from finance literally can't cross over into engineering space unless you specifically build a route for it, essential for multi-tenancy.
Yeah. Right, so isolation keeps things secure, but once you've built this complex network, maybe with thousands of devices, how do you keep their configurations consistent? And how do you even know if something changes when it shouldn't? That configuration drift idea, the source mentions a compliance dashboard. What's the deeper value there? Is it just about knowing what it should look like?
Well, it's more than just knowing. The material points to the compliance dashboard in Aruba Central as the tool for this. It lets you define a baseline or maybe a golden configuration for your devices. But the real power, I think, is that it actively tracks deviations. It spots that drift.
Ah, okay. So it's proactive.
Exactly. It shifts things from reactive troubleshooting, waiting for a call saying something's broken, to proactive health management. You're not just fixing problems after they happen. You're seeing configurations drift before they cause an outage, ensuring things stay consistent and secure. It's about preventing issues.
Okay, consistency across the board. Now let's zoom in a bit, back to basics almost. Connecting two switches together. If that link needs to carry traffic from, say, multiple different VLANs, virtual LANs, what kind of port do you absolutely need?
Yeah, this is fundamental network plumbing. The source clearly calls out trunk ports. Trunk ports are specifically designed to carry traffic from multiple VLANs over a single physical connection.
How does that work?
Magic. Not quite magic. They do it by adding a tag to each data frame. This tag identifies which VLAN the frame belongs to. So even though traffic from VLAN 10 and VLAN 20 might be physically on the same wire between switches, the tags keep them logically separate. Without trunks, you'd need like a separate cable for every single VLAN between your switches. Imagine the mess.
Yeah.
So yeah, trunks are essential for VLAN communication between switches.
Got it. Trunk ports handle the multiple VLANs. Now, let's talk about making sure the right traffic gets through first. Think about voice calls, video conferencing, real-time stuff.
Yeah.
Delay or jitter is just awful for those. How do networks make sure that kind of critical traffic gets priority?
This is all about quality of service, or QoS. And a key mechanism mentioned is strict priority queuing in AOS-CX. What this does is it creates different queues for traffic, and it gives absolute top priority to certain classes. So if you configure voice traffic for the strict priority queue, it means voice packets are always forwarded first, period. Before any email, before any file transfers waiting in other queues.
Always first, no matter what.
In that strict priority model, yes. It ensures that latency and jitter, those delays and variations in arrival time, are minimized for the applications that need it most, like voice and video. It's critical for that smooth, real-time experience.
Okay, smooth experience is one thing, secure is another. Let's go deeper into security, down at layer 2, the link level. Suppose you want to encrypt the traffic directly on the wire between two switches using MCSec. What's the absolute prerequisite for that encryption to even start working, for them to agree on keys?
Right. MCSec provides that hop-by-hop encryption, but it doesn't just magically turn on. The source makes it clear. MCSec fundamentally relies on 802.1x for device authentication and key exchange. Typically, this involves EAP methods, Extensible Authentication Protocol. Think of it as a secure way for the two switches to prove their identities to each other.
So authentication comes first.
Absolutely. The critical point is, without 802.1x authentication, secure encryption keys cannot be negotiated between devices. That initial handshake, that proof of identity, is non-negotiable. It has to happen before the secure MCSec tunnel can be established. It's foundational for layer 2 encryption.
Okay, authentication before encryption. Makes sense. Now let's tackle something tricky in routing. Say you have a network using ECMP equal cost multipath. Traffic should balance nicely across multiple paths, right? But sometimes you see asymmetric routing, traffic goes out one way, comes back a totally different way. What causes that, according to the source?
Yes, asymmetric routing. It can make troubleshooting a nightmare because the path isn't predictable. The source highlights two main reasons this can happen, even with ECMP. First, unequal bandwidth per path. Even if the path is supposed to be equal cost, if one link is actually faster or has more capacity, routing protocols might favor it for outbound traffic, but maybe return traffic calculates the path differently.
Okay, bandwidth differences. What's the other one?
The second one is misaligned routing policies. This is often trickier. It means the rules dictating how traffic is routed aren't consistent. Maybe router A has one policy, but router B, handling the return traffic, has a slightly different one. Or policies on redundant devices don't quite match up.
So physical differences or configuration inconsistencies.
Pretty much. Both can lead to that unpredictable asymmetric flow.
Right, got it. We've talked building, securing, troubleshooting. What about the future? Making networks smarter, more automated. How can they not just spot problems, but maybe even start fixing themselves? The source mentions the Network Analytics Engine, NAE, and AOS-CX. What kind of tasks is that really suited for?
NAE is definitely pointing towards that more intelligent, automated future. It's about moving towards self-driving or maybe self-healing networks. The source lists three really good examples of what NAE can do. First, it can monitor CPU and memory metrics, keep an eye on device health. Second, if something goes wrong, like a CPU spike, it can configure email alert notifications to let admins know.
Okay, monitoring and alerting. Standard stuff.
Yes, but here's the cool part. Third, it can create auto-remediation scripts. So NAE doesn't just see the CPU spike and send an alert. It can be programmed to automatically run a script to, say, restart a process or apply a temporary fix.
Ah, so it takes action itself.
Exactly. It enables monitoring, alerting, and automated remediation. It's about fixing problems faster, sometimes before a human even needs to get involved. Big step towards smarter network operations.
Automated fixes, that's pretty powerful. Okay, let's switch gears slightly to access control, but still keeping it dynamic. Thinking about downloadable roles and what's called a dynamic segmentation setup. This is where user policies get assigned on the fly when they connect, right? What two things absolutely have to be configured for this to work?
Yeah, downloadable roles are super flexible for access control. Instead of configuring policies statically on every switch port, the policy gets pushed down from a central server. The source identifies two essential pieces. First, the switch itself needs to be integrated with a radius server, specifically mentioning integrated ClearPass with switch radius. ClearPass is HPE Aruba's policy manager, often acting as the radius server.
Okay, integrate the switch with ClearPass Radius. What's second?
Second, the actual roles and policies must be defined in ClearPass. ClearPass is where you build the rules. What VLAN a user goes into, what firewall rules apply based on who they are or what device they're using. Then, when someone connects and authenticates via Radius, ClearPass sends the name of the role down, and the switch applies the corresponding predefined policy. So ClearPass integration and having the roles defined in ClearPass are the two must-haves.
Okay, makes sense. Central policy definition pushed down dynamically. Let's wrap up with one more diagnostic scenario. Network stability. If you're running OSPF for your layer 3 routing, and you suspect there's a dreaded routing loop traffic just going in circles, what are the two classic symptoms you'd look for?
Routing loops. Yeah, definitely something to avoid. They can kill performance and cause outages. The source points to two telltale signs. The first is constant route flapping.
Flapping, you mean routes appearing and disappearing?
Exactly. In a loop, routers might learn a path, then learn a conflicting path through the loop, withdraw the first one, re-advertise it, and so on. It creates constant instability in the routing table.
Okay, flapping routes. What else?
The second symptom is seeing low TTL in traceroute results. TTL is time to live. It's a number in the IP packet header that decreases every time it crosses a router. If a packet is stuck in a loop, it keeps hopping between the same routers, and its TTL value drops very quickly. So if you run a traceroute and see the TTL count down to 1 or 0 really fast without reaching the destination, that's a strong indicator of a loop.
Got it. Route flapping and low TTLs in traceroute. Key things to watch for. Hashtag tag 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 outro. All these concepts we touched on, redundancy, security, automation, they're constantly evolving to make sure those digital interactions you rely on are fast, reliable, and secure. It's a complex dance happening beneath the surface. Thanks for joining us for this deep dive. We'll catch you next time.